Alright, so this video is about y-axis solids. So just like we can draw a function and revolve it around the x-axis, we can also revolve it around the y-axis. So if you look here, we have the graph y equals x squared, and we're going to take y equals x squared from 0 to 2 is spun around the y-axis. So we're going to figure out the volume as it spins around the y-axis. Okay, so this is what we're worried about here. But now we're spinning it around the y. So we're getting kind of like a little bowl or cup or whatever. But if we do just this, y equals x squared, we just integrate that from 0 to 2, we're going to get the area underneath it between the curve and the x-axis. But we don't want that. We want all of this area here. So what are we going to have to do? Well, first thing we're going to have to do is we're going to have to solve this for x equals. Okay, so you have y equals x squared, take the square root of both sides, x equals square root of y. Alright, so now we know we're going from 0 to 2 on the x-axis. Okay, but what does that mean we're going to on the y-axis? Because now we have to refer everything to the y-axis. Well, since we know x is going to be 2, just plug it in here. 2 squared is what? Well, it's 4. Okay, so we're going from 0 to 4 now on the y-axis. Let me erase this so I got some room to write. Okay? So now you set up your integral the same way. Our volume from C to D. I'm using C to D to differentiate that we're on the y-axis, because on the x-axis I use A to B. So on the x-axis I use A to B, so on the y I'm going to use C to D. We're still going to have to multiply by pi, because remember, all of these are going to give us little tiny circles that we're going to all add together. But now, f of y squared will be our radius, and then, of course, dy. So now we're going to go from 0 to 4 of pi times the square root of y squared dy, okay, which equals, you have from 0 to 4, you have pi times y dy. Because remember, the squared and the square root cancel out. So when you take the antiderivative of this, you get pi times y squared over 2. We're going to evaluate from 0 to 4. Of course, plugging in the 0 gives you nothing. Plugging in the 4 gives you 4 squared times pi, which is 16 pi over 2. And that'll reduce down to 8 pi. So the volume of our little bowl or cup here is 8 pi. Okay? So as you can see, the process is done the exact same, except we have to solve our equation now for y, and then we have to figure out our to and from now for the y-axis, not the x-axis. Okay? So it's pretty much the same, except now you have to have everything in terms of y instead of x. Now, this one. What happens if we're revolving something now not around the x or y axis? For instance, in this case, we're spinning it around the line y equals 1. Alright, we're going to spin it around the line y equals 1. So what are we going to do here? Well, we know that the distance from this line down is 1. So we're going to have to subtract 1 from our equation. So our new equation is going to be y equals x squared plus 3 minus 1, or y equals, negative x squared plus 2. Okay? So now that brings us down to the x-axis. Okay, so now we're down here doing the integral of this. But now we still have to figure out where to go from and to. How do we do that? Well, you take your original equation, okay, and we know that when we hit this line, all y value is 1. How do we know that? It crosses the line y equals 1. So take your negative x squared plus 3. You need to take your original equation, okay, You need to take your original equation and set it equal to 1 because that's where it's revolving around. And now solve. So minus 3, so negative x squared equals negative 2. Okay. Since this is negative and this is negative, multiply both sides by negative 1. So now we have x squared equals 2. Square root, x equals plus or minus the square root of 2. So now, instead of these question marks, we know we're evaluating from negative square root of 2 to positive square root of 2. All right? And then this is now our new function that we're going to evaluate. At negative x squared plus 2. All right. So now let's find a volume. Our volume is going to equal negative square root of 2 to positive square root of 2 of pi times negative x squared plus 2 dx. You take your antiderivative, substitute in the square root of 2 and then the negative square root of 2, subtract the 2, and you should get 18.956. Okay, that's something you should be able to do. And the only difference here is multiplying it by pi. So I'm really not changing what you're used to doing by throwing in the pi. You just know that you just leave the pi alone until you get done. You just bring it along for the ride and then you multiply it out when you get finished. You don't integrate pi, it's just a constant, so you don't integrate pi. Alright, let's look at our last example. This is our last example for this video. We want the volume of a solid formed by f of x equals cosine x revolved around the line y equals negative 1/2. So now we have to do the same thing. We have to raise this up by 1/2. Okay? We have to raise it up by 1/2. So our new equation is going to be y equals the cosine of x, all right, plus 1/2. So this is what we're going to integrate, is this equation right here. And then, of course, you would set the cosine of x equal to negative 1/2 and solve, and you would come out with this point here is 2 point, well, I don't know why I'm putting decimal form. This would come out to 2 pi over 3, and here it would come out to 4 pi over 3. Okay? So now we're going to take the integral, our volume. We're going to take the integral. Now keep in mind, since we added the 1/2, we brought this up to here. So now we've moved up to here to take this area. Okay? Because now we're revolving it around the x-axis instead of revolving it around a line 1/2. So this is going to be 2 pi over 3 to 4 pi over 3 of cosine of x plus 1/2 dx. You integrate that, and you have your answer. I'm going to leave this for you to integrate. It's not difficult, but I'm going to leave this for you to integrate and find the answer. Ask me tomorrow, I'll give you the answer. All right. So, this has been, well, it was titled y-axis solids, but I kind of got off topic, which is fine. So now you know how to find a solid when you revolve your function around the y-axis, or when your function is revolved around another line other than the x-axis. All right? Remember, you have to move it back up or back down to the x-axis. Okay? So watch this video, make sure you understand what we went over. See you tomorrow.